All right, so now number 24. Let's take a look at number 24. Number 24, we start out with 8 to the negative 1/4 power times the third root of 32 is equal to 2 to the x power, right? So it's different ways we could start this off, but I decided to just convert 8 to the negative 1/4 power into a radical, right? Into a radical. So we got this 8 to the negative 1/4 power became 8, or the fourth root of 8, the fourth root of 8, but in the denominator though, right? Because if I multiply this by this, if this has a negative exponent, actually, this would really be rewritten as 1 over 8 to the 1/4 power because of the negative exponent. That's called the negative exponent rule, right? So then if I had that and I multiplied it by this, it would end up looking like this. The third root or the cube root of 32 over the fourth root of 8 equal to 2 to the x power. And then what did I do next? I broke this 32 down into 8 times 4. Now, why did I do that? Because I wanted to simplify the radical. Because I know that 8 is a perfect cube. 8 is a perfect cube, meaning there's a whole number that can be multiplied by itself and then by itself again to equal 8, which is 2. That's where this 2 down here came from, because the cube root of 8 is 2. The 4 can't come out, though, because the 4 is not a perfect cube, right? So then what did I do next? And I kind of was just experimenting with this problem, just trying different stuff out. You know what I'm saying? Because I want to get my bases the same so that I could create an equation where my exponents can be equal to each other. So I got 2 times the third root of 4, or the cube root of 4, over the fourth root of 8. Then I flipped this again. I put everything back into rational exponents. I was just, like I said, just experimenting. I don't even know why I did that. Just trying something out to see if it was going to work. It did. So 4 to the 1/3 power, and then 8 to the 1/4 power, because that's just how you convert a radical into a rational exponent, right? Where'd the 1 come from? The 1 is the exponent that the 4 has. There's no exponent written, so the exponent is a 1. Where'd the 3 come from? The 3 is the root from the radical sign. So you got 4 to the 1/3 power. And then we got 8 to the 1/4. Where'd that 1 come from? The 1 is the exponent that the 8 has. The 4 is the root of the 8, which is the denominator. So then in your numerator, what did I do? I'm trying to have the same base. I want everything to have the same base. So I got a 2 over here. Already got a 2 right there. So what I do is, like, I flip this 4, make it into 2 to the second power. 2 to the second power. And what did I do to the 8? The 8, I make that 2 to the third power. Make the 8 2 to the third power. And then you still got the 1/4 exponent outside. Still got the 1/3 exponent outside, right? So then we got, what we looking at? Okay, we got 2 times 2 to the 2/3 power. Why 2/3? Because again, I can multiply the exponents together. The exponent outside the parentheses, gets multiplied by the exponent inside the parentheses. So that's going to be 2 to the 2/3 power. Same thing down here. You do 1/4 times 3. That's 2 to the 3/4 power, right? So you got 2 times 2 to the 2/3 power over 2 to the 3/4 power. Now, what can I do? Now, this is 2, but it's also 2 to the first power. So I can use the multiplication property to combine these two, right? But actually, no, that's not what I did. Check me out. I used the division property first. That's what I did. Use the division property first. So 2 to the 2/3 divided by 2 to the 3/4. You got to subtract the exponents. You got to know how to subtract fractions. This is 2/3. This is 3/4. We can't just do 2 minus 3. We can't do that because our denominators are not common. They're not the same. We need common denominators. The common denominator would be 12. So this is the same thing as 8/12. This is the same thing as 9/12. So then you do 8/12 minus 9/12. That gives you negative 1/12. Negative 1/12, right? Negative 1/12. So then I got 2 to the first power times 2 to the negative 1/12 power. And then multiplication property of exponents. When you got the same base, you add the exponents. So 1 is the same thing as 12/12, right? Because I could represent it like that. Because again, I need common denominators. I got a 12 over here, and this would be 1 over 1, but I can make it 12/12, right? Because 1 is equivalent to 12/12. So I do 12/12 plus negative 1/12, which is 12/12 minus 1/12, which is 11/12. So now I got 2 to the 11/12 on the left-hand side. I still got my 2 to the x power on the right-hand side. It's been there the whole time, right? So now my bases are the same, so I can create an equation where the exponents are equal to each other. And once I do that, I got 11/12 equals x. It's no more work to do. I'm all done. 11/12 is equal to x. So x is equal to 11/12. That's called the property of symmetry, right? when 11/12 is equal to x, and x is also equal to 11/12. So it doesn't matter what side of the equal sign each of these terms is on. So that's how you do a problem like this. Hope that helps.